Welcome to the world of biomimicry. It is often said, imitation is the highest form of flattery. Bionics, or biomimetics, is a new scientific discipline, seeking to build artificial systems based on biological ones.
This discipline has already shown a number of innovations and breakthroughs in the fields such as architecture, communication, or flow control. A flower is unfurling from the bud. How do these large flowers find room in such a small bud? Why, so to speak, do they unfurl without facing any major deployment problem?
Here we learn that nature is an expert in the science of folding. Biological folded structures do not occur in a fantasist way, but following mechanical rules and constraints. Inspired from the ability found in nature to fold structures, several researchers have already developed new folding and deployment strategies to optimize packaging and deployment in space. Unfolding techniques developed by nature also minimize the mechanical strains on the structures being deployed. One famous folding technique inspired from nature is the Mura-Ori technique that is currently considered for use in the deployment of solar sails. Another remarkable feature of nature is its ingenuity in developing social processes amongst individuals, thus making the process of the group infinitely more complex. Amongst these natural societies, we find insects such as ants and bees. The contribution from each bee is very modest. However, as a body, the community to which it belongs can perform collective tasks that none of its individuals would ever dream of achieving. No surprise, therefore, that some scientists are already dreaming of micro-robots capable of mimicking the bee to explore the surface and the atmosphere of other planets. After billions of years of evolution, nature has developed materials and structures which optimize strength and weight. Scientists and engineers realized that stiffened with phenolic resin, honeycomb panels would be strong enough to be used in aircraft construction. From an aircraft to a spacecraft, the step was in this case easy to make. Honeycomb panels are in the size of many spacecraft.
Man is dreaming to use the exceptional properties of the spider silk. The elasticity of this natural material is much higher than the elasticity of synthetic materials.
If we could copy the spider's chemical wizardry, imagine how it could be put to use in vastly improved seat belts, artificial ligaments, lightweight lines and cables with possible applications for tethered satellites.
In summary, biomimicry is a young scientific discipline seeking to build artificial systems inspired by biological ones. It is a multifaceted discipline involving a wide diversity of fields like electronics, technology, informatics, medicine, biomechanics, chemistry, physics, and mathematics.
The main motivation to develop biomimicry has been the permanent quest from engineers and scientists to optimize the systems they design. Three main areas of application are today being investigated: the mechanical structures, the processes, and new biomaterials. In each one of these respective domains, nature has developed and tested strategies to optimize the stability and weight of mechanical structures, as well as to optimize the energy consumption versus task performed. And finally, the optimization of strength and elasticity of biomaterials are remarkable. Biomimicry is a new way of viewing and valuing nature. It introduces an era based not on what we can extract from the natural world, but on what we can learn from it.